Friends, welcome once again to our chemistry class. In today's class, we are going to talk about electrochemical cell. Remember, we are done with electrolytic cell, that part that dealt with electrolysis, their electrolytic cell. Now we are into electrochemical cell. Now, what is electrochemical cell? It is a device which converts chemical energy to electrical energy. See diagram below. Now this diagram shows electrochemical cell. Now let's try to understand the diagram. This is a beaker. This is another beaker. Inside this beaker, I poured a solution, zinc tetraoxosulfate 6 solution, into this beaker, and in this one I poured copper 2 tetraoxosulfate 6 solution into it. Now after that, I dipped an electrode here. The name of the electrode is copper plate, and that is my cathode. And in my anode, I dipped zinc plate into it. This is zinc plate. Now I connected a wire into voltmeter from this half cell. This is another half cell. I connected wire also into this voltmeter. The cell is incomplete, and I have to put a salt bridge to complete the cell so that electron can start to flow. And after doing that, this salt bridge is what makes it complete. And after that, electrons start flowing from the anode to the cathode, meaning oxidation takes place at the anode and reduction takes place at the cathode. Now, what that means is that this plate, zinc plate, will dissolve and then go into solution. Atoms on the surface of this plate, which is this, will ionize, meaning will give out 2 electrons each. One atom of zinc will donate 2 electrons and itself will turn to zinc ion. Once it turns to zinc ion, it will not continue to remain on the surface of the plate. Instead, it will fall into the solution in the form of what? Zinc ion, Zn2+. Now, electrons, the 2 electrons are flowing upward to the voltmeter, and you see a movement on the pin on that voltmeter showing that electron is flowing. Now when that is done, those electrons will pass down to the cathode. Now remember, this solution is made up of zinc or copper tetraoxosulfate 6, copper 2 tetraoxosulfate 6 solution, and which means that copper ion is in this solution. This copper ion from the solution will move down to the plate as the electrons are flowing down. Move down to the plate because it has already lost 2 electrons. As it is going to the plate, the 2 electrons are coming. It will collect the 2 electrons back and becomes copper atom, not copper ion again. Copper ion from the solution, collecting 2 electrons from the plate that are flowing down, returns to copper atom and deposits itself on the plate. It will no longer be in the solution. It will be part of the plate. So with time, you can see that this plate is building while this one is reducing in size. Now, when that is done, this is what happens at the anode. Half cell equation, they will ask you to write, and this is what happens at the cathode. This is half cell equation. They will ask you to also write. Remember, this is oxidation and this is reduction. Good. When that happens, you can see with me that there will be increase in the number of zinc ion in this solution because the plate is ionizing. Zinc atoms are losing their electrons and are falling into the solution to increase the number of zinc that are already in the solution, the number of zinc ion that are already in the solution. Nothing happens to this SO4 2 minus in the solution. The number are still the same, but as these ones are falling in, the copper, the zinc ion are falling in, they are increasing the number of zinc ion in the solution. So now here at the beginning, the same thing, the number of copper ion and the number of tetraoxosulfate 6 ions present, they were the same. But with time, because copper ions are moving away from the solution to be part of electrode, and then SO4, nothing happens to it, the number are still intact. Now you can see that there is a reduction in the number of copper 2 ions in the solution, while there is increase in the number of zinc ion in the solution. Tetraoxosulfate 6 remain the same. Now, because you have more plus here than, remember this can be in this form, zinc 2 plus, and this is what, SO4 2 minus. The same thing with this one, it can also be Cu2 plus and what, SO4 2 minus. So since there is decrease in the number of these in this solution and there is increase in the number of these in this solution, but this and this are still the same. This one that there are few of these, the leftover, assuming they are 50-50 before, now they are 30-50. The remaining 20 that has no plus will move through this salt bridge down to this. This will move through the salt bridge because they don't have Cu2 plus that can neutralize them there, to come here and meet the excess 20 of these that have dissolved and then come into the solution to neutralize it. So the anions can move from one half cell of the system to the other half cell of the system through salt bridge, and not the cation, but anion can move. The side that has more will move to the side with fewer ones to balance the system. Good. Note 1, at the anode, that is at the half cell of zinc. At the anode, zinc will dissolve. This is the plate, zinc plate, dissolve and then goes to solution. This is zinc ion going to solution. The 2 electrons flow down to the other side of the half cell, and that is what, oxidation. And at the cathode, that is at copper, you have the solution. The copper 2 ions from the solution will obtain 2 electrons that are flowing from the other half cell down to it. It will obtain it and becomes part of the plate. That is what, reduction. Now the overall reaction means adding this and this together. Now what is common is 2 electrons. They can cancel themselves out. If you cancel this, that means you are left with zinc plus this copper ions, arrow zinc ion plus copper plate. So this is the overall reaction, meaning the addition of the two half reactions. Now this is what happens. Now let's see salt bridge. It serves to prevent the mixing of zinc tetraoxide 6 and copper 2 tetraoxide 6 solutions, but allows the passage of this SO4 2 minus under the influence of current. I have explained all this. I just want you to recall. The excess SO4 2 minus ions from the CuSO4 solutions move through the salt bridge into the zinc tetraoxide 6 solution to neutralize the effect produced by the excess positively charged zinc ions and maintain the electrical neutrality of the both solutions. All this I have explained when the diagram was here. So now I am giving you note on it. If you wish to copy it, you can do that just now. Now salt bridge can be prepared using, just look at it, preparation of salt bridge. It can be prepared using filter paper. You know filter paper, you fold the filter paper and make it to be just very long, slim like this. Then you carry it and soak with, prepare also sodium chloride solution, concentrated sodium chloride solution or potassium chloride solution as it is here, or ammonium trioxonitrate 5 solution concentrated. So when you prepare any of the three solutions, you carry the filter paper, soak it inside it, soak it, dip it, allow it to be wet, and then bend this side, bend this other side. You remember we were using two beakers. When you bend this side, fix it. This leg should go inside one beaker, while this leg should go inside one other beaker. You have prepared your salt bridge. Now let's look at the function of salt bridge. 1. To complete the electrical circuits. I talked about that. 2. It hinders the mixing of the two solutions. You saw that. 3. It enables the movement of anions from one half cell to the other so as to maintain electrical neutrality. So we have already said about that. Now let's see the differences between electrochemical cell and electrolytic cell. Electrochemical cell, this other side, electrolytic cell. Number 1, under electrochemical cell, it converts chemical energy to electrical energy, while electrolytic converts electrical energy to chemical energy. Reaction taking place is spontaneous. Reaction taking place is non-spontaneous. Number 3, the two half cells are set up in different containers. The two half cells are set up in the same container. Number 4, salt bridge is needed. Salt bridge is not needed. Number 5, anode is negative. Anode is positive. 6, cathode is positive. Cathode is negative. 7, electrons flow from anode to cathode. Electrons flow from cathode to anode. I believe you enjoyed the lesson. I wanted to share the lesson. Share it. Share the channel. Like it. Comment. And then keep following. If you did not study or listen to watch other videos before now, what you are doing now will be like a dream to you. So better you watch all those videos that I taught before now for you to be able to flow with us very well. Thank you. See you some other time.